Hello everyone, welcome back to AEROHUB and welcome to the series of lectures in Gate Aerospace Flight Mechanics. And in the last lecture we discussed about how to estimate the aerodynamic center as well as center of pressure for a given airfoil section, and I have introduced you some standard formulas. And in this lecture we will discuss one of the important problem in flight mechanics. The following data refers the test on airfoil. Okay, this is a aerodynamic test of an airfoil, and when CL is equal to 0.25, the pitching moment about quarter chord point is minus 0.041. When CL is equal to 0.6, the pitching moment about quarter chord point is minus 0.037. Okay, so we have two set of data here having both the value of coefficient of lift and pitching moment about quarter chord point. Calculate the center of pressure location corresponding to CL 0.5 for the above airfoil. So they are asking, they have given one CL, that is 0.5. At this particular value of coefficient of lift, we have to find out the value of center of pressure. Okay, at this particular value of CL, I have to find out the value of center of pressure. Okay, so to find out the value of center of pressure, I need to find out the value of coefficient of moment about aerodynamic center, that is CMAC, as well as I need to find out the position of aerodynamic center. These are the two factors I have to find out the value of center of pressure at the given value of CL. Okay, so to find out the value of center of pressure, I need these two values. So first of all, I will find out the value of coefficient of moment about aerodynamic center. Okay, so I will introduce to you one important formula. Cm at a particular point n is equal to Cm about aerodynamic center plus n minus aerodynamic center into corresponding CL. This is our equation number 1, and this is one of the important formula. Okay, so the formula we are discussing in this lecture, by using these formulas I can solve any problem related to aerodynamic test data. Okay, so this is nothing but the coefficient of moment about any point. N is nothing but the point about which we need the aerodynamic quantity. For example, in this case the value of n is quarter point, that is 1/4. Okay, here the value of n is 1/4 because they have given the value as Cm c/4, that is Cm about quarter point. Okay, so I have to find out the value of CMAC. So I will substitute the value of Cmn, that is nothing but Cm c/4. Okay, I will be getting two equations. So first equation I will use this data, and the corresponding CL is 0.25. The value of n is 1/4, that is 0.25. So Cm n, that is for first one, minus 0.041 is equal to CMAC plus n is 0.25 minus aerodynamic center into CL. CL for first test data is 0.25. Okay, and second one is 0.037 is equal to CMAC plus 0.25 minus AC, and the value of CL is 0.6. Okay, so this is the two equation. Now I can get the value of CMAC as well as the aerodynamic center AC from these two equations. Okay, so I will do that very fastly. So I'll multiply this CL into the bracket, so it will be minus 0.041 CMAC plus 0.0625. I am multiplying minus 0.25 AC. Then second equation 0.037 is equal to CMAC plus 0.15 minus 0.60 AC. Okay, so I got this equation. Okay, I put this equation as equation number 2 and this equation as equation number 3. Okay, now from this equation number 2 and equation number 3, I have to find out the value of CMAC as well as the value of AC. Okay, so what I will do is I will multiply equation number 2 into, we can see here we have a part 0 minus 0.60 and we have 0.25 here. Okay, so I will multiply equation number 2 into 2.4. That is, if 0.25 into 2.4 is equal to 0.60. Basically, I am eliminating this part. Okay, so I will be getting, I am taking this part in this side towards this side, so it will be minus 0.1035 is equal to CMAC minus 0.25 AC into 2.4. I multiplied here and this also multiplied here. Okay, 2.4 entire equation. Okay, so and this will be going this side, minus 0.187 is equal to CMAC minus 0.60 AC. Okay, so I will be getting and just minus, so this value will be equal to minus 0.2484. Okay, so this is 0.60, this is 0.60 only. Okay, so this will be, this value will be, if I am multiplying by 2.4, it will be minus 0.2484. Okay, so finally I can cancel out, this will be also 2.4 CMAC. Okay, so I will be getting finally 1.4 CMAC is equal to minus 0.0614. Okay, don't confuse this thing. I am just multiplying this equation by 2.4 and just subtracting, that's it. So I will be getting this answer. So finally I will be getting CMAC is equal to minus 0.0614 divided by 1.4. So this will be minus 0.04383. Okay, this is the answer of pitching moment about aerodynamic center. Okay, now I got the value of CMAC. I can substitute in any equation. For example, I will substitute in this equation. I will be getting the value of AC. Okay, so I have this equation here. Minus 0.87 is equal to CMAC minus 0.60 AC. So I will substitute the value of CMAC. We got the value of CMAC from the last equation. That will be minus 0.187 is equal to minus of 0.04385. This is the value of coefficient of moment about aerodynamic center we found out in the previous step. Okay, minus 0.60 AC. So after solving, I will be getting the value of AC. So I am writing the answer directly. We can solve that. So the value of AC is 0.2386. This is the value of AC. Okay. Now they are asking to find out the value of CP at CL is equal to 0.5. So I have one more equation. CP is equal to Aerodynamic Centre minus CMAC divided by CL. Okay, this is an important equation in flight mechanics. Okay, CP is equal to AC minus CMAC divided by CL. And you have to understand the position of center of pressure will be always varying, and the position of aerodynamic center is always a constant. Okay, so the substitute the value of aerodynamic center, CMAC and CL. Okay, so I'll be getting CP is equal to 0.2386 minus the CMAC is my negative, it will be minus 0.04385 divided by 0.5. So finally I'll be getting the value of CP as 0.23263. This is the value of center of pressure of the corresponding airfoil when the value of CL is 0.5. Okay, so that's all about this lecture. If you have any doubt, you can just ask in the comment section. Thank you for listening. Take care.